Hi everyone, today we'll be presenting our research project on ecological succession in Point Pleasant Park. My name is Lily and I am presenting with Luke and Rowan.
Point Pleasant Park is an urban Acadian forest in the south end of Halifax, Nova Scotia, with both coniferous and deciduous trees. The park is highly diverse following the intermediate disturbance hypothesis, where moderate human activity and coastal effects maintain high species diversity. On September 29, 2003, Hurricane Juan, a Category 2 storm with wind gusts up to 185 kilometers per hour, destroyed about 70% of the tree canopy, resulting in the closure of Point Pleasant for 9 months. The forest is recovering through secondary succession, since the disturbance did not alter the soil and tree species are recolonizing the area. From 2004 to 2025, data was collected annually. Total tree density was measured using diameter at breast height. Dominant species densities were recorded for red spruce in 2004 and red maple in 2025, and species diversity was measured using Shannon diversity in H. Point Pleasant Park also has historical significance as a traditional spiritual gathering site for the Mi'kmaq Nation known as Ambigati. Data trends presented in our study aligns with other literature showing that land abandonment allows natural regeneration and forest structural recovery within 40 years.
6 20 by 20 meter plots in Point Pleasant Park, or Ambigati in Halifax, Nova Scotia, were selected because they were heavily impacted by Hurricane Juan in 2003, allowing long-term monitoring of forest recovery in secondary succession. All living trees with a diameter at breast height, or DBH, of 2.5 centimeters or greater were measured at 4.5 feet above the ground using a diameter tape, and species were identified using iNaturalist and A. Peterson Field Guide to Eastern Trees. DBH was used because it provides an estimate of wood volume and allows comparison with both scientific and industry data. For each year, from 2004 to 2025, tree density per species was recorded as trees per 400 square meters, with missing data in 2005, 2007, 2016, and 2020. Linear regression was used to model changes in species density over time and quantify trends and rates of change during succession.
Question 1 asks, how and why has the overall forest community changed over time? As well, what can we predict will happen to the overall forest community as it moves towards its climax community? And why? Total density is a strong indicator of the overall forest community and gives insight into recovery patterns, which is why I chose this metric. That being said, our objective is to quantify how Hurricane Juan has changed the total density in Point Pleasant Park Forest to better understand the forest succession trajectory towards a climax community. Our null hypothesis is that there is no significant relationship between the total density and year, and our alternative hypothesis is that there is a significant positive relationship between total density and year.
Question 2 asks how the density of the dominant species in 2004, red spruce, and the dominant species in 2025, red maple, changed over time, and what this means as the forest approaches a climax Acadian forest. Our objective is to examine density changes of red spruce, or Picea rubens, and red maple, Acer rubrum, in Point Pleasant Park from 2004 to 2025, identify trends between the two species, and predict how their densities may change as succession progresses. Our null hypothesis is that there is no significant relationship between year and the density of red spruce or red maple. Our alternative hypothesis is that there is a significant positive relationship between year and the density of both species.
The objectives of this question are to analyze overall species diversity in Point Pleasant Park from 2004 to 2025, predict how diversity will continue to progress, and determine the driving forces for the results measured. Our null hypothesis states the Shannon Diversity Index for Point Pleasant Park has shown no significant change from 2004 to 2025, while our alternative hypothesis states the Shannon Diversity Index for Point Pleasant Park has shown a significant increase from 2004 to 2025.
A linear regression was created to examine the relationship between total density and time in years since disturbance. As seen in Figure 1, the regression shows a statistically significant relationship between total density and year. The total density significantly increased over time, rising by an average of 7.93 individuals per 400 meters squared each year, indicating a positive linear relationship between the total density and year. Therefore, We rejected the null hypothesis that there is no significant relationship between the two. Hurricane Juan has caused a significant loss in forest canopy cover. Any massive loss in coverage for the ground disrupts the ecosystem balances and processes below the trees. Initially, the light availability greatly increases in exposure of the understory, inviting pioneer species to initiate ecological succession. Pioneer species improve the habitat by increasing soil quality through the decomposition of organic matter and other nutrients. Ultimately, they build a more stable environment by allowing more individuals to establish, increasing total density and helping in recovery.
For red maple, or Acer rubrum, we analyzed yearly density, measured in trees per 400 square meters in Point Pleasant Park, or MacNutt, from 2004 to 2025 following Hurricane Juan in 2003. Data was missing in 2005, 2007, 2016, and 2020. Linear regression showed that red maple density increased over time, with a slope of 2.24 trees per 400 square meters per year, an R squared of 0.135, and a p-value of 0.0003. The null hypothesis is then rejected, indicating a significant positive trend as shown in Figure 4. For red spruce, or Picea rubens, we analyzed yearly density, measured in trees per 400 square meters in Point Pleasant Park, or MacNutt, from 2004 to 2025 following Hurricane Juan in 2003. Data was missing in 2005, 2007, 2016, and 2020. Linear regression showed that red spruce density increased over time, with a slope of 0.35 trees per 400 square meters per year, an R squared of 0.131, and a p-value of 0.0004. The null hypothesis is rejected, indicating a significant positive trend as shown in Figure 5. Red spruce was the dominant species in 2004, and its density increased slowly over time at about 0.35 trees per 400 meters squared per year. Red maple was dominant in 2025 and increased faster at 2.24 trees per 400 meters squared per year. These changes reflect patterns of secondary succession following Hurricane Juan. Red maple is an early to mid-successional pioneer species. It quickly exploits canopy gaps and establishes seedlings rapidly. Red spruce is a late successional, shade-tolerant species, growing more slowly as it gradually fills the forest understory. This matches the general pattern of secondary succession described by Moles and Lorson. Looking ahead, red maple will continue to dominate in the short term by filling gaps quickly. Over the long term, red spruce is expected to increase and eventually take over as a late successional species. Overall, the density growth of both species will slow as the forest approaches a climax Acadian forest.
Shannon diversity values measured at Point Pleasant Park were plotted into a linear regression analysis. As seen in Figure 6 and the results of our statistical test, an overall increase from 2004 to 2025 of H was recorded. There was a significant positive relationship between H and years, demonstrating that as time goes on, species diversity increases. As a result, we reject our null hypothesis in favor of the alternative hypothesis. There is an overall significant increase in H between 2004 and 2025, indicating that the chosen community metric has changed over time, supporting the idea that secondary succession is occurring. This increase in diversity is due to the storm destroying the old uniform canopy, allowing for more efficient occupation of different strata by different species, creating a multi-layered canopy. Predictions state that species diversity will follow a saturating pattern where it continues to increase till H plateaus in late secondary succession. H will continue increasing as there would still be strata to occupy, leading to more diversification. However, as vertical strata availability decreases, so will availability for differing species to grow, resulting in the stabilization of H, returning the forest to its original state before the disturbance. Hurricanes Dorian and Fiona were similar in magnitude to Juan, however Point Pleasant Park sustained minimal damage from these storms. Hurricane Dorian sustained wind speeds up to 155 km per hour, while Fiona sustained wind speeds of 160 km per hour, compared to Juan's 185 km per hour. Compared to the 9 months it took for Point Pleasant to reopen for debris removal and restoration efforts caused by Juan, the park was only closed for a week after Dorian and even less, 3 days after Fiona. Point Pleasant was able to fare better against these storms as Juan pruned the vulnerable trees, making way for different species to create a more resilient forest as a result of secondary succession.
As the forest is located in an urban setting, human and pet disturbance, especially in the form of soil compaction and trail clearing, can alter succession. As outlined by the Halifax Regional Municipality, a multitude of practices are being executed to reduce the harmful effects we have on the forest. These forest management practices can ultimately shape species composition, density, and diversity. For example, by removing non-native trees, native trees experience less competition and could ultimately accelerate the rate of succession by increasing native plant diversity. On the other hand, the park management could also adopt practices which slow natural succession. Although the management preserves debris, if they were to clear vegetation by mowing trails or open areas instead of having access restrictions and preservation, this would interrupt the succession by causing pioneer species to remain dominant.
Pioneer species like mosses, fungi, and bacteria are the first to colonize disturbed soil. They improve soil by adding organic matter, nutrients, and increasing moisture and microbial activity. If these pioneer species are limited, soil development slows, seedbed conditions worsen, and early tree recruitment is reduced or delayed. This affects late successional trees like red spruce by slowing their establishment, delaying succession to later stages, and potentially altering species dominance in the forest.
Figure 1 shows increasing density beginning to slow, but has yet to plateau. This suggests competition is beginning to intensify, a characteristic of the mid-successional stage. Alongside total density, mid-succession is supported by the significant increases in red maple and red spruce densities. These findings indicate the development of intermediate and shade-tolerant species. Finally, the increasing Shannon diversity indicates the overall biodiversity rising and becoming more stable. As previously mentioned, Point Pleasant Park is an urban park where human disturbance can be a concern. Urban forests are more susceptible to littering, non-native species, trampling, and trail creation, all of which emphasize the importance for active forest management to maintain biodiversity and the natural forest systems. The phrase Msit Nogma means the interconnectedness of everything, which is a reminder to us to be mindful of our actions and the broader implications they have on our surroundings. In Point Pleasant Park, this can serve as a reminder to try and minimize our ecological footprint when visiting urban forests.
We would like to acknowledge our lab instructor, Dr. Joanna Zaguris, our demonstrator and teaching assistant, Jovia Gallant, and our lab group, which includes Lily MacNutt, Luke Lavine, and myself, Ron McNeil. We would also like to thank all of Biology 2060 ecology students from 2004 to 2025 who collected the tree density data that made this study possible. We thank the park staff and management of Point Pleasant Park and the Halifax Regional Municipality for maintaining the park and allowing long-term ecological monitoring and student research. Finally, we acknowledge that our study took place on the traditional lands of the Mi'kmaq Nation, known as Amdugity, and we respect their stewardship and ecological knowledge of the area. Thank you for your attention during this presentation.